in the good morning to those of you here in the United States, and good afternoon to those of you joining us from Denmark. Welcome to our webinar, Maximizing the Benefit of Food Waste Recovery, Exploring the Danish Model and Anaerobic Digester Technology for Wisconsin. My name is Chris Voll. I'm the head of Biogas and Waste for the Danish Trade Council of North America, and I'll be acting as moderator for today's session. Today, I'm representing both the Danish Biogas and Wastewater Alliances, which is a collection of companies looking to share knowledge in these sectors with US and Canadian stakeholders. I'm joined in the webinar today by my colleagues Cecilia Sorensen, Sebastian Terkelsen, and Sophie Thorgard from the Wastewater Alliance, who have been instrumental in putting this together today. I want to first thank the speakers from our alliance companies for sharing their time and insights today with us from Denmark. The Midwest, and especially Wisconsin, is a primary focal area for the Trade Council of North America due to the potential for growth in the biogas sector and the many willing and interested parties that exist in the state. Today, in fact, we are joined by almost 100 attendees, primarily from Wisconsin, representing state agencies, project developers, engineers, universities, food companies, municipalities, and last but not least, farmers. All of the parties that are necessary to help this industry grow in the state. I see lots of familiar names in the attendee list, but also many new ones as well. So I want to thank you all for taking the time to join us. Also want to thank very much our collaborators on today's webinar, the Water Council and the Wisconsin Biogas Council for working with us on this today. And with that, I'd like to introduce first Karen Frost, who's the Vice President of Economic Development and Innovation with the Water Council, to make a few remarks. And then secondly, Matthew Chrisman, the Executive Director of the Wisconsin Biogas Council, to share a few opening remarks as well. So first Karen and then Matthew. Thanks.
Well, good morning or good afternoon, everyone. Thank you so much for joining today's session. The Water Council is pleased to be working with the Danish Trade Council and the Wisconsin Biogas Council and the participating companies to bring this information to you today. Just a tiny bit about the Water Council. We are based in Wisconsin. We're a nonprofit organization that works with industry, academia, and utilities in the water tech and water sector to connect and bring information of value and connections of value to our network. So this webinar is one example of some of the work that we do. But we also partner with international organizations, including the Danish Trade Council and many others across Europe and across the globe, to foster relationships and then to provide one-on-one support to companies who are looking to grow or expand or begin their business in the United States. So that's just some of the work that we do. And like I said, we're very pleased for you to join us today and hope you get a lot out of the session. Thank you.
Thanks, Karen. Matthew? Matthew, can you, if you're with us, make sure you're unmuted?
Sorry about that. I guess it didn't click.
There we go.
Well, good morning, everyone. Thank you for attending the Maximizing the Benefit of Food Waste Recovery, Exploring the Danish Model and Anaerobic Digestion Technologies for Wisconsin webinar. The Wisconsin Biogas Council is proud to partner with the Danish Trade Council and the Water Council in order to provide you with the most important information needed when considering the opportunity and processing technologies involved in food waste recovery. The Wisconsin Biogas Council's mission is to advance the biogas economy of Wisconsin through collaboration, education, and research to achieve sustainable communities, environmental improvement, and energy independence. In the 2020-2021 Wisconsin Department of Natural Resources statewide waste characterization study, organic wastes were the largest category of waste found in landfills statewide. Wasted food represented 14.5%, with a further 6% composed of inedible food scraps. Additionally, Wisconsin food manufacturers struggle to find locations to process food production waste and off-spec or expired products. This is a tremendous opportunity to create beneficial use of organic materials and the most efficient processing pathway instead of increasing costs through consumption of landfill space or attempts at processing at wastewater treatment plants that are not designed to take large quantities of food materials. The ability to have depackaging operations in Wisconsin is also required. Denmark has a strong tradition of processing waste streams for maximum beneficial reuse, and speakers today will provide an excellent overview of the Danish model. Thank you for attending. I look forward to learning more and supporting the developments in this market.
Thank you, Matthew and Karen, for those opening comments. Very much appreciate the collaboration on this effort. Few administrative details. We're going to do a short poll in a moment to find out who we have on with us today. If you have any questions, please submit them through Zoom, and we will get to as many of those as we can. There will also be a short survey that will activate as you sign off, whether that's at the very end or sometime throughout. We'd appreciate your feedback on that. And then at 10:30, we will be wrapping up, and we will stay on if any interesting questions for the presenters. If none, we will conclude at that point. So with that, we're going to roll right into our program, and happy to announce my colleague, Cecilia Sorensen. Cecilia is a commercial advisor with the Biogas and Waste team with the Trade Council of North America. She's been my colleague for the last year and a half. And Cecilia will provide kind of an overview of the biogas sector in Denmark and how it has scaled over time, and provide some insights on how that may affect Wisconsin's growth. So with that, I'll turn it over to you, Cecilia.
Thank you, Chris. I think before I start my presentation, we should do the poll. So I know that our technical supporter will put on the first poll now.
Yeah, sorry. Thank you, Cecilia. So as I said, the vast majority of the people are from Wisconsin. And again, unfortunately, we did not have all of the possibilities that I mentioned earlier, but we do have a good mix of people here from these various sectors. So again, thank you all for joining us. We need everybody there to help make this successful. Cecilia?
Yeah, thank you very much, Chris. Thank you for the introduction. As Chris said, I'm a commercial advisor within our waste and biogas team, and I'm very excited to get the opportunity to give some insights of the Danish biogas sector and how we see biogas as a circular economy driver in Denmark. During the next, during the next 10 minutes, I would love to talk a bit more about what has happened in the Danish biogas sector for the last decade. But first, I think it's important just for all of us to see which country and which state we're actually talking about today, since we have focused in on Denmark and Wisconsin. So the left side of this slide is Denmark and the right side is Wisconsin. These two places are more than 4,000 miles apart, but they're actually pretty similar in many ways, especially when it comes to the actual land. Even though Wisconsin is 3.3 times larger than Denmark, they're very much alike when it comes to the land, the agriculture, the big impact that the agriculture has on both Wisconsin's economy, but also Denmark's. So I just make this short table for you to get a comparison of Denmark and Wisconsin. We can see that when it comes to population, we're actually pretty much alike. Yeah, I think let's take the next slide. So Denmark is a highly agricultural intensive land, just like Wisconsin. We actually in Denmark produce 3 times the food that we consume. And this also means that we are highly dependent on having some environmental solutions for this intensive and sustainable agricultural production. To some, we are all known for our climate policies. The first one you can see here, or the other one, where we have a goal of actually becoming climate neutral by 2050. And that also involves us using food waste as a resource for biogas and fertilizer. So Denmark actually acknowledges that there is no net zero if manure and organic waste are not treated through anaerobic digestion. The next thing is that, as you can see here, 34% of all energy production in Denmark is renewable. And Denmark is really trying to address food waste. We have a lot of national laws that go in and dictate how to treat waste, how to achieve the net zero. And one of them is a national law from 2023, which states that all municipalities, they have to manage their food waste. In the US, we right now see that we have more than 60 million tons of food waste, or we see that more than 60 million tons of food is waste or tossed annually. And most of it is actually going to landfills right now. This is really a shame because we don't acknowledge the resources and the energy that we actually have in our food waste. In Denmark, we no longer build these landfills. I think one of the key takeaways from this slide is that in Denmark, we do have a high tradition of working together. Like you can see here, I've listed government, private, and academia. So this high level of trust that we have in Denmark means that the universities, our policymakers, our companies, we all work very closely together, which has definitely affected our biogas sector and our development. It was more than a decade ago where Denmark actually chose to go into anaerobic digestion and biogas capture as a primary management method. And this has definitely allowed Denmark to generate a great amount of renewable energy, but also nutrient fertilizer. Quickly want to mention the map you can see here to your right. It's a map of Denmark. All the green dots are actually all the biogas plants that we have, which have upgrading technologies. And the yellow line you see, the full yellow line is our national gas grid. Next. Speaking of our national gas grid, Denmark is now a world leader when it comes to having biomethane in the gas grid. Biomethane is also what I just referred to as upgraded biogas. We currently have 22% of biomethane in our grid, which is a world record. And one of the other near-term goals that we have of the sector is to reach 30% by 2023, so by the end of next year. We also have one that says we have to reach 50% by 2025 and 100% by 2040. This slide is to show you how Denmark has transformed from farm-based to industrial scale. Right now, we see more than 170 biogas plants in Denmark. The Danish model and these biogas plants are very much characterized by large-scale centralized plants where we do co-digestion, but still with manure being the primary input. This centralized model means that we secure our feedstock from normally it's between 5 to 100 farms, or like we have this network of farms, which all range from a distance within 10 to 25 kilometers of the biogas plant. On the other graph you see here to the right, you can see how we use our biogas production in Denmark and how it has developed for the last decade as well. You can clearly see with the red mark on the diagram that a lot has happened when it comes to upgrading in the last decade. We clean our biogas more, we upgrade almost all of it right now so that we can inject it into the national gas grid. And this is of course related to our very near-term goals when it comes to having biomethane in the grid. During the last at least 6 years, almost a decade, actually all the new biogas plants that we build in Denmark, they do have upgrading technologies. So right now, more than 80% of all our plants actually also upgrade the biogas to the grid. Next. So why do we see digested biogas as part of this circular economy? I really want to highlight that biogas and biogas production in general is not just an energy solution for how to produce renewable energy. We also see it as an agri-environmental solution for how to handle waste in different sectors, so that it is a technology that has way more appliances than just for energy. On this slide, you can see some of the advantages of doing digested biogas. And I'm not going to go through each point. You can all read them, but I just want to remember, or want everyone to remember, that biogas is a renewable energy source, creating the most jobs locally when we per $1 million invested. And these jobs are often in rural areas where every job counts. Next. So when we talk about, again, the Danish approach, it is circular economy. And we are using waste. We are not using a high level of energy crops like many other countries in Europe. Actually, we have a law saying that we can maximum have 5% of use of crops in our biogas plants. But another thing of this Danish approach is that we see a high level of cooperation between the different farmers, where we also have the contract between the farmers and the biogas plants. And this owner or this cooperation means that it gives us the security of the supply, but also getting rid of the digestate from the biogas plants. Denmark chose, next. Oh, sorry, one back. Couldn't see it now, I have it. And Denmark chose anaerobic digestion and biogas as a management strategy for how to treat our organic waste stream from both industry, agriculture, and households. Again, it is a natural biological process, and it yields not only nutrient-rich fertilizer, but also renewable energy, which is all part of the circular economy. Next. So this is a graph we have borrowed from one of our Danish companies, Nature Energy, which Nature Energy is actually currently building projects in Wisconsin. But we just want to show with this one how Denmark's green circular economy approach actually is to biogas and anaerobic digestion. I encourage everyone to take a closer look at this after today, but especially pay attention to the entire waste, manure, other organics area. You can see how it's picked up, transported. We mix it with different feedstocks for the biogas production. We do get out a digestate that can be used as biofertilizer in the fields. And this fertilizer is actually a very high value fertilizer. So it's very important and attractive for our farmers. In the middle of this picture, hopefully you can see it. You can see that we're referring to CO2 and H2. This means and indicates that part of the Danish approach is also that we are seeing a more growing movement to capture and how to use the CO2 component after the RNG production. Next. When we talk about biogas as a circular economy driver, it's very important to highlight some of our main Danish companies and frontrunners within this sector, not only in Denmark, but also globally and in the US. So this slide and the next slide will include our 8 different alliance companies that are all leading biogas companies in Denmark and are all currently looking into the North American market. And the lower right picture here is a typical Danish biogas plant from Nature Energy, but this one is actually the first Nature Energy is the first fully integrated renewable natural gas company. They deploy large-scale digester systems, and Nature Energy designs, builds, finances, owns, and operates the projects and the plants. This slide, I'm not going to go into too many details, but you can see the 7 other companies. But after my presentation today, you will hear more about Gemidan, Renew, LSM, and Novozymes. So they will all get that chance to talk about their amazing technologies and how they have developed the biogas sector in Denmark. But just want to mention Stjernholm. They have a sand remover grid washer technology. We have Ammon Gas to the right. They do upgrading with an amine scrubber. And they actually upgrade more than 80% of all the upgrading plants we have in Denmark. And then we have in the lower left corner, Biogas Clean, which does biological H2S removal. If you want to know more about biogas production in Denmark or the Danish approach to anaerobic digestion, you're very welcome to reach out to Chris, me, or one of my other colleagues. Earlier this year, we actually, together with our Biogas Go Global partners, developed this magazine catalog with 60 pages, which gives a really good insight into the Danish biogas sector and share experiences and lessons learned. It's available in English and also 6 other languages. I think that was it for me. Hopefully it was not more than 10 minutes, but I'll give the word back to Chris.
Great, Cecilia. Thank you very much. That's an excellent overview. And I think we are a little bit behind, not due to your presentation, but I think we'll save questions for the end. So please submit those as you see fit. Actually, the first presentation I'm going to be doing, because unfortunately our colleague Lars from Gemmet and Ekagi is tied up and not able to join us today. So I'll actually be making the first presentation in the technology panel. So if I can ask for Gemmeden's presentation to come up, and I'll get started on that. Next slide, please. So Gemmeden Ekagi is a company that has a food waste pretreatment system. Their overall philosophy is to extract energy and nutrients, as Cecilia just discussed, from organic waste sources. Their system, which you'll see through the presentation, is very flexible. It creates a biopulp that can be used for multiple different purposes. And the system has very low operation maintenance and labor costs. Next slide, please. Gemmeden Ekagi is part of a larger company called Gemmeden that's been in the organic waste resource business for more than 30 years. Ekagi, if you are throwing organic waste away in Denmark, there is a very, very high chance that it is going through a Gemmeden Ekagi system. They have 4 commercial scale facilities that have been operating starting in 2012. The latest project that you'll see a picture of went into operation in 2020. These range in size, with the newest one being 120,000 tons per year. Gemmeden is a full service company, as you can see. And the important thing is that their system really was designed to extract the organic fraction of waste with contamination in mind. Next slide. This is a picture of a standard Gemmeden Ekagi system, and you'll see it in all of its glory here shortly. We often hear the term depackaging systems. Gemmeden Ekagi, I say, is not just a deep packaging system. It's a fully integrated technology that does extract organics from packages, from plastic, from paper, from cardboard, and produces a biopulp. But unlike many of the depackaging systems that have been deployed here in the US, that really were not made for producing a biopulp, this is in a category all its own. Next slide, please. So this gives a sense of the types of food waste that this system can handle. In Denmark, as Cecilia mentioned, there is already a start on removing food waste and other organics from the residential stream. And there has been more attention paid on the commercial and industrial sources in the past. So as you can tell, these waste streams are coming in bags from households, on pallets from food manufacturers, and this can be off-spec beer, cheese, yogurt, whatever the case may be. And as you can see in the bottom right, this produces what is called a biopulp, which is then delivered to anaerobic digestion facilities throughout Denmark. Next slide. Here is a photo, just very quickly. The one in the upper left-hand corner is the newest one that serves the Copenhagen region, and that's the 120,000 ton per year facility. The one in the bottom middle is up in the north part of Denmark. And as you can tell, those two are standalone facilities that were purpose-built for the Gemmen and Eckergi system. The bottom left, the only thing I'll bring to your attention there is the system can be retrofitted into existing facilities. And in this case, it went into a municipal waste to energy facility where the technology is deployed. And the picture on the right is what the system looks like. And it literally is that clean from the systems that I've seen operate. Next slide. And now the bulk of my presentation is actually going to be a video that Gemmen has. It's about 4 minutes long. But, you know, a picture is worth 1,000 words and a video is worth a lot more. So let's watch the video and then I'll wrap up my presentation. Give us just a few seconds. Here we go.
Gemmen Eckergi is a revolutionary technology capable of mechanically converting organic waste into a biopulp that can be used for energy and fertilizer. The system is designed to efficiently receive, process and get rid of organic waste. First, the lorries cross the weighbridge, where all accessible data about the waste are recorded and stored as documentation as required by law. The system is designed to be able to efficiently handle all types of lorries. The delivered waste is either tipped into the receiving pit or directly into the receiving hall. The system and the technology are designed to be able to handle waste enclosed in all types of packaging. Plastic, metal, glass, and cardboard. After this, the process of processing the packaged organic waste begins. The waste is loaded into a feed hopper by a front-end loader. In this system, the feed hopper is capable of operating for about 4 hours, but it can be adapted as required. Once the feed hopper is filled, the automatic process begins, in which the packaged organic waste is conveyed up into a small feed hopper by a screw conveyor. This process helps enhance the efficiency because the feed hopper fills the pulper very quickly. The pulper is a large rotating centrifuge in which waste is mixed with water, quickly dissolving the mixture into a mash-like substance called biopulp. From here, the biopulp is sent to a separator, which separates the inorganic material from the organic material, to send a more than 99.9% pure organic pulp to a storage tank and onto tankers destined for biogas plants. The plants extract the biogas from the biopulp as an eco-friendly, sustainable alternative to fossil fuels. The degassed residual product from the Eckergi system is spread as biofertilizer on farmland, thereby contributing to the circular economy. Back at the facility, all the separated inorganic materials have been sorted out. The dry materials are recycled wherever possible. The inorganic material left over can be sent to an incineration plant which converts your waste and mine into district heating, benefiting all of us once more. Help us to be kind to our environment. It's simply common sense, and green at that.
Great. I am going to leave that as the end of the presentation, and on behalf of Lars, if you could go to the next slide, Sebastian, on behalf of Lars Nielsen, the CEO, there is lots and lots of data about this system, lots more information we'd be happy to share to whoever might be interested. Thankfully, we have had some good initial discussions with a number of people in Wisconsin about this potential solution. So thank you on behalf of Gemet and Ekagi. And with that, we will continue. We'll save all the questions for the end. I want to make sure each presenter has their time. Our next presentation is from Paul Einar Rasmussen. Paul Einar is the CEO of Renew Energy. Renew is an engineering consulting firm and has more than 20 plus years of experience in the US market and even more around the globe. Renew is one of the founding partners of the Biogas Alliance. And with that, Paul Einar, the floor is yours.
Thank you. Thank you, Chris. Yeah, let us get started. Biogas is a driver for circular bioeconomy. That's important. And we have, let's say, all the organic waste produced by the ecosystem, food materials which goes into society, and we do have waste coming out of it from both sides, and it can go into anaerobic digestion in a co-digestion. It's a quite important, let's say, place to focus on. I mean, you have the waste from the food production, and you have the waste from the food consumers. It goes back, and they are treated in an anaerobic digestion, which will produce biogas and produce nutrients, which can benefit for the farmers again. Next. Fertilizers, you could say after nutrient recovery, it goes back as a fertilizer to farms, and biogas will be treated accordingly. It can go into power generation. It can also be treated and go into the gas grid as a renewable natural gas, which is the most common today. We call it a biorefinery in total. Next, please. What is going on? That is important to understand. We have biomass, which can be stable biomass, it can be liquid, and it goes into a digestion system, anaerobic digestion, with a multiple step of a process. We have hydrolysis as a first step, we have acidogenesis, we have acidogenesis, and we have bacterogenesis. It means that first the bacteria will split the biomass into acids, and then the acids will then be transformed to fatty acids, and which will be consumed by the methane producing bacteria. This is a complex process which has to go on in a digester, and under certain conditions. If the conditions are available, it will be a very stable process, and it will be self-containing in a mix between acids and ammonia, which keeps a buffer balance. We will produce biogas, which is a mix of methane and CO2, and we will produce biofertilizer and water. Next, please. Let us focus a little bit of the digestate management, which is important. Let us say that we have 100% biomass coming in. It will consist of about 80% of water. There will be some ash content, which are 4%. There will be more stable biomass, and there will be some which are digestible, 10%. We will get gas out of it, and we have to deal with the digestate, which can be approximately 90%. The rest will be water, minerals, etc. And that is the challenge to deal with. We can put all into one tank and deliver it back to the farmers, but it's not always possible. We need to be careful on how we can do it. Next, please. We used to divide, the total biogas system in a front end and in a digestion process and in a back end system. We have food waste, which can be dealt with, like we saw in the Gemidan. So we get a pulp, which goes into the digestion. We need to have preheating, and we need to have pre-mixing in order to get as good digestion. We will produce gas, and we have two options. One is to upgrade the gas, to take the sulfur out and to deliver it into the gas grid. Or we can take the sulfur out and we can take it into a gas engine and produce power and heat. We will also need to look on the digestate backend, and there are two ways. One is to deliver it back to farmland as a land application, or we can do a separation system, which we have a patent system in US patent, and we will have a first step. It will be a kind of a mechanical separation to get a solid fraction out. Then we can do ammonia stripping, which will allow us to go further into cleaning, maybe even to produce processed water and nutrients. Next, please. This is just to explain our US patent, which gave us the opportunity to do let's say a complete system. Next, please. It's described here, and I can share it with you if you are interested. Next, please. We are always talking about the Danish style of mixing. Danish style means a CSTR digester, complete mixed digester, where we have feedstock coming in. We have a top hang, let's say, mixer with a bottom propeller and a top propeller, which allow us to an optimal system. We will have a heat exchanger outside, so we have no internal, let's say, coils inside to deal with. Everything is outside and pumped around, so we have a very reliable and low maintenance system. This is important. At the same time, digesters are built by a galvanized surface, or etc., and we have a stainless steel on the top where we have the gas system that allow us to have digesters which can stay for 20 years or more. Next, please. We have been in US for many years. We have built one project in Michigan in 2012. We are built here in New Jersey a biogas project dealing with 300 tons of food waste per day, producing 3 megawatt of power. Construction started in 2018 and commissioning is going on. There are still some running in optimization, but it's a project which are built next to a wastewater treatment plant. And
Paul, one minute, please. Okay, this is Chris. 1 minute.
okay. And then next, please. The system is a pre-treatment. We have depacking, we have digestion, and then we have gas processing, and then we have nutrient recovery, meaning that we can deliver the effluent back to the wastewater treatment plant. No problem. Next, please. There are digesters to see. We build them in 5,000 cubic when digesters can be built even up to 9,000 today. We have gas holder, we have gas engine, decanter centrifuges, and ammonia stripping. Next, please. We will not go further. We have several, let's say, references in Denmark also. Yeah, next, please. We have our office in southern part of Denmark, and we are doing development, design services for biogas and biorefinery. We have 30 years experience plus, and we are working in Europe, in several states. We are also starting up in South Korea. And of course, we are involved in US in projects in New Jersey, in Michigan, in Illinois, Chicago. Have a project in Florida, which are going to be financed shortly. So, and finally, we have a project up in New York State. And that's a project dealing with several dairy farms. Interesting, in Cayuga County. So it could be a model also for Wisconsin. I think that's, I have to say, I'm short in time, so thank you. I will be pleased to answer questions.
Great. Thanks, Paul Einer. And, you know, we're going to save the questions for the end just to get through all the presentations. But Renew is definitely a world leader when it comes to the co-digestion of manure and other feedstocks. And we rely heavily on them, as do many of the other alliance companies. So thank you, Paul Einer, and we'll get some questions. I know lots of good ones are coming in, so please keep those going.
Okay.
So thanks, Paul. Without further ado, we're going to switch gears. Our next presentation is from Søren Rasmussen. He's the sales director at Landia. They're a world leader in mixing and pumping solutions for anaerobic digestion and biogas and other sectors. And so, Søren, I'll turn the floor over to you.
Thank you, Chris. And yeah, thanks everyone for attending. So if you don't mind, just stay on the first slide just for a sec. Thank you. Landia is a family-owned company headquartered in Denmark. It was established in 1933. We do a lot of different things, but I assume those of you attending this seminar here is you're mostly interested in co-digestion or food waste digestion to increase your biogas yield. We do that in both the municipal digesters as well as industrial and ag-based digesters. Next slide, please. Landia manufactures a lot of different products, but the one I'll focus on today is our chopper pumps, because when it comes to turning food waste into a digestible slurry. The chopper pump is a very handy product to have. As you saw in the video from Gimmedan, if you have heavily contaminated feedstocks, or if you have a lot of plastics and metal, etc., their system is the ideal way to depackage that and produce a biopulp. But within that plant, there are a number of Landia chopper pumps that help pump this biopulp. And also, if you have food waste from other sources that aren't that requiring depackaging, you may be able to use a chopper pump directly without the larger depackaging facility. So the chopper pump itself was invented by Landia in 1950. It was designed to handle dairy manure, so all the straw and chunks, bits and pieces in there that would otherwise clog the pumps that were available in the market. Landia invented the chopper pump to take care of that. So the pump itself has a hardened steel knife system that sits in the front of the pump inlet, and it macerates all the solids, be it straw or chicken bones or whatever kind of waste you have, before it's pumped on into the process. Next slide, please. So these next few slides are just examples of some of the food waste that you might experience. It varies, right? And every region has its own, kind of various food or feedstock sources. Sometimes you have source separated organics with a lot of plastic bags, and that's where you would want a depackaging system. But if you get more clean waste that just needs to be reduced in size and turned into a pumpable slurry, then it could look something like this. Or the next slide, please. This is fish and shellfish is in Scandinavia and in Canada, Chile. Different regions have a lot of seafood that we basically chop up and turn it into to this pulp that can be digested. Next slide, please. Yeah, or tomatoes, other different sorts of green waste. It could be corn, it could be different agricultural products. Next slide, please. So one of the an extension to the chopper pump, so to speak, is our biochop unit. It incorporates a tank with the chopper pump. So again, if you have already depackaged waste, or if you have things without a bunch of metal and glass and plastics in it, you can dump it all into this tank, and it's basically like a big blender that homogenizes the feedstock, makes it available for digestion. Next slide, please. So this could be poultry, or slaughterhouse waste that we convey into the tank, and as you can see on the right there, is being blended into this nice slurry. Next, please. Or if you happen to get your hands on some pork bellies, we can make those available for digestion as well. Being Wisconsin, I should have probably included some cheese pictures here, but this is just to illustrate some of the feedstocks we work with, and quite frankly, it is more challenging to chop up a chicken than a piece of cheddar. So I hope you get the gist of it. The next slide, please. So I also have a little video here. You may actually, in the beginning of the video, you may actually recognize some of it, because this is part of the video is from a Gimmedan plant. And what you see in the first image here on the screen is from the same Gimmedan plant that we just saw a video of with the Landia chopper pump there. Now, we don't do the depackaging. That's Gimeda and Ekogi doing that. We pump the biopulp afterwards. So you can probably play that there. So that's essentially what biopulp or food waste slurry looks like. We both mix and pump. We, in addition to the chopper pumps, we manufacture propeller mixers and other types of mixing system to keep things homogenized. But this is essentially your biopulp that would go into the digester. And like I said, the chopper pump has been around for some 70 years now. It's been used in the biogas sector for some 30 years. Landia is we do have a subsidiary, a U.S. office that has been around for a little over 20 years. We work a lot in the municipal market and in biogas plants, where we have thousands of these pumps and mixers installed all over the U.S. So our engineering and service facility in North Carolina can help with pretty much any project you might have. So if you are considering food waste co-digestion, you may need a food waste storage tank. It could look something like this, where we use the chopper pump for keeping the tank mixed. Or the next slide, please. Or it could look something like this, where we use a propeller mixer for mixing. These are all individual solutions that will tailor to fit each specific project. And yeah, next slide, please. That's all I had this time around, but please don't hesitate to contact us if you want to learn more about our solutions.
Soren, thank you very much. And, I'm sure those of you on can tell that this Landia's suite of different products is very complementary to Gemet and Ekigi, not only as part of their solution, but Landia focuses a bit more on the organic and food waste that is already or never made it into packaging. So along with Gemet and Ekigi in this, it's a great combination of solutions. So thanks, Soren, and we'll do some questions at the end. So thank you for your presentation.
Thank you.
Next up, we have Dan Christofferson. Dan is the General Manager North America for LSM Pumps. And Dan will give us a bit more about LSM. They're a specialized hose pumping company with applications across many different sectors in the biogas sphere. So with that, Dan, I'll turn it over to you.
Thank you, Chris. And thank you for the Trade Council for hosting this. In addition, and right next to the fine presentation we just had. So we are also a pump company. Next slide, please. We are a hose pump manufacturer established in '82 in Denmark, privately owned and operated. We manufactured the first hose pump in '93. Now with sizes from 1/4 of an inch, and then we just launched a 12-inch. So capacity from 0.7 and then approximate 1,500 gallons per minute. We are actually the proud manufacturer of the largest hose pump in the world. We're pretty proud of that. The hose pump have been around for quite a few years, but our pump have a very unique design. So we use rollers instead of shoes. So that gives us a quite lower energy consumption than what you would normally see on a hose pump. Next slide, please. So where is the hose pump used? Pumping food waste, wastewater and sludge direct from we just talked about the packaging equipment. and pre-screening. If you look at the middle top picture, it's actually from a just finished project in North Carolina with Orbit Energy, where we do all the pumping solution for them. We also quite good at pumping biomaterial to and from the mixer tanks and direct to the digesters. So where we diversify is actually we can pump high fiber content, grit, and other impurities. That's not a problem. If you look at the right top corner, is from a biogas plant in Denmark, where we do the suction direct from the underground mixer tank. We also quite good at pumping manure, both before and after sand separation, and also for long distance pumping. For instance, we are doing a project right now, pumping 5 miles of manure. And in this case, it'll only require a 7.5 kilowatts motor. We've done it. The oldest application is actually still in operation in Germany to this day. He's pumping hog manure over a 2 mile stretch. We hope to have a case story ready within the next few weeks, but it's actually more than 10 years old and still operating full speed ahead with the original pump house, motor, gearbox, whatever. Quite nice. We also put in pumps for the circulation between the digesters. I didn't put a picture of that actually, but and we also have for the injection of the glycerin if you have any additional product that you need to inject. So in these applications, where we benefit and why we are preferred, if you have pistons pump, it's not a complete steady flow. The energy consumption is also significantly higher, and they're quite expensive to operate. Another thing is we replace a lot of pumps with from the eccentric screw pumps or the low pumps. The maintenance costs are significantly higher on those, and they are not coping the sand and grit fairly as good as we do. We actually did a case story not long ago, cutting the expenses by 2/3. You'll see the middle lowest picture is from K Agro in northern Jutland. They have, I think we are at 5 of the largest 6-inch pump right now. From the US, we have references from CR&R in California. We also are working with Waste Management, Orbit Energy, Energia, SNF, and Disney World. And then we have a very nice collaboration with the Forcia consultancy up north. Next slide, please. If you see the left top corner is actually for the food production facility. It's our stainless steel type. It's also FDA approved, and it actually have the what they call the SIP clean in place, meaning that if you look at the picture in the middle, you don't have any media touching the pump parts, the inner parts. It only passes through the hose, so it's quite efficient for that. The pump itself, there's no mechanical seals, there's no packing. It's self-priming, and it's quite high suction capacity. Again, if you look at the middle picture, I think it gives a good example of how it actually operates. It's a seal construction, and whenever you stop the pump, you have no backflow since the rollers are actually depressing the hose. It also means that depending on sizes of the pump, you can actually have solid and large objects can actually pass through the pump without damaging. Still keep in mind that if you have anything short or whatever, it can damage a hose internally. We can actually pump up to 80% solids. We did an all-on-volunteer test not long ago, where we actually were above 85%. the customer stated that it was basically dry cement, and the pump still chugged along, but his check valve didn't pass the test, so to say. Another thing with the pump is actually we can reverse the rotation quite easily. Basically, when we run with the VFDs, you can just, with the toggler, you can just reverse it. The pump itself is really easy to fit any other applications or production lines. You decide whether you want the inlet at the top or the bottom, of course, depending on what type of material you have. We have multiple add-ons, just to name some: the temperature sensor and pressure leak detection. We have the VFD, variable frequency drive. It can adapt to any PLC that you might have. We also have dampeners depending on piping layout, and basically whatever desire a customer may have. Next slide, please. So why an LSM pump? What we're actually quite proud of that, but it's really easy to work on for people on site. It's important to know that any technician can work on it. So typically a hose repair or hose replacement, sorry, it takes around 1 hour to do. There's no special tools that you need to buy. There's no special training that you need to send or whatever. And it's actually pretty easy to adapt. We have different flanges. We have different adapter pieces that you can run with it. For an operation, it's also important to know that there's very few parts that you need to have on stock. What we recommend is basically a hose and some hose clamps, perhaps a door seal. Might over time need a roller or two and an axle, and that's basically it to own and operate an LSM pump. Everything is standard, so motor gear is standard. It's not special made. It's not special stuff that you need to buy from us. It's fairly easy to get. If you have any questions at the end, please go ahead. If not, contact me directly. I'll be happy to help.
Great, thanks, Dan. Another great solution as we start to move into the food and food production waste sector. I've seen some incredible videos of some LSM pumps actually pumping salmon, whole salmon at a fish processing plant. So thank you for that overview. So last but not least, we have Lindsay Tucker. Lindsay is a technical sales specialist with Novozymes North America. I'm sure Lindsay will provide a little overview of Novozymes, but they're a very, very large company in the biological solutions space and have been focusing a lot more on biogas of late. And so with that, Lindsay, the floor is yours.
Thanks, Chris. So I wanted to talk a little bit about using enzymes to enhance food waste degradation and biogas production. So Novozymes is the largest industrial manufacturer of both microbes and enzymes. And what that looks like, just from a few numbers to give you an idea of the size and breadth of the company, is we've got over 6,000 employees. We make over 700 different products in over 30 different industries, and we're present in over 130 countries. Next slide. In some of those industries, just to kind of give you an idea of where enzymes might already be kind of impacting your day-to-day life, some in the agriculture and industrial biosolutions group, the water and waste division, which is what I'm a part of, textile and leather, the animal health and nutrition over in consumer biosolutions, enzymes in detergents to help get your laundry cleaner with less surfactants, in the soap that you use in your dishwasher for the same kind of goal, in the beer that maybe you have in your fridge, or maybe in the dairy products that you buy, especially applicable maybe for some of you Wisconsin folks, But if you've ever seen lactose-free milk in the store, well, a lot of times it's our enzymes that are helping to break down that lactose so that that milk can be enjoyed by more folks. Next slide. So a lot of times enzymes and microbes have name recognition, you know what they are, but not necessarily a super clear idea of how they work in an industrial fashion. I'm guessing a lot of the people on this call have an idea how microorganisms impact anaerobic digestion, but kind of just to summarize, those two components help to catalyze processes and build up or break down molecules. So to give a couple examples that tie back to some of the industries I was just talking about, they can help make cleaner clothes with less energy, better nutrition with less waste, greener fuel, and if you're growing crops, higher yields with less pesticides. Okay. So kind of to look at how those can be applicable in anaerobic digestion, which is kind of what we're here to talk about today. So if you look, I'm not great with Zoom, or I would figure out how to do a pointer or something here, but if you look at that picture in the upper left-hand corner here, we're talking about reduced viscosity. So enzymes can help break down that food waste and expose some of the sugars or other parts of the food that wouldn't as easily be accessed by the microorganisms otherwise. So that tends to make it into a little bit more of a slurry without as much chopping going on. So you still need some of the mechanical agitation. We need to reduce some of that particle size, but it helps without adding extra water to bring that viscosity down and make the food waste more manageable. It can also help with improved separation of rejects. So in the picture down just below the other one about reduced viscosity, you can see an example of how that breakdown might look without enzymes versus with enzymes. And what's happening there is a lot of times maybe some cardboard or some more fibrous food materials aren't able to be separated into the organic fraction because they behave more like inorganics. But if you're using enzymes to kind of chop those large particles into smaller, more digestible particles, then they can be used in that organic fraction the way you would normally want them to be, which results in making, if you combine that with reduced viscosity, it allows you to separate out some of that plastic, metal, glass a little bit more easily without losing any of the components to that kind of slurry that you're getting that can provide energy to the digester. So some of the other things that can occur, you can see increased throughput with enzyme addition. So if you're able to have a higher dry matter content in the substrates that you're putting into the digester, because you're not needing to add as much water, then you're able to increase that throughput. You may see a reduced retention time because the microorganisms are more easily able to access the energy and the nutrients that are being fed to them, and can help with reduced foaming incidents or floating layers, because all of that's more easily digestible. And kind of all of that comes together to increase the biogas yield that you're seeing with the plant. So that's kind of the short and sweet summary of how enzymes can be useful and an integral part in a biogas production facility. So thanks, Shal.
Thanks, Lindsay. You know, as you could all imagine on the webinar here, we all know that biogas and especially renewable natural gas these days, fortunately, has a very high value. So being able to produce more biogas, being able to put more material through your system with the addition of something like enzymes would be very welcome from a lot of people. We have had some questions that have come in, and I'm going to start, now that everyone has made their presentation, I'm going to start the Q&A session. I'm going to try to mix together some that have come in along with some that I have. And I'm going to kind of go backwards here. So Lindsay, I'm going to start with you. Thank you for your overview. I do know that you have done some initial kind of commercial scale testing of your enzymes. And while I realize that, these are preliminary findings and not necessarily definitive, can you kind of share some of the results that have been seen from some of your partners out there, and what this might mean to other people in the biogas world?
Yeah, of course. Thanks, Chris. So I'd say kind of my caveat before this is that your results may vary just depending on the substrates that you're feeding to your digester. That mix is really going to be kind of dependent on what exact kind of performance benefits you might see. But we've seen a increase in the biogas yield from about 10% up to about 20%. And I would say one of the kind of quickest and most obvious things that folks have seen is just an increase in that stability of biogas production. They're not seeing some of the dips, the peaks and valleys that maybe they might have seen earlier with different substrate mixes coming in. You're seeing more consistent production of the same level of biogas.
Great. And just a second quick question. I believe you're currently, Novozymes is looking for partners to both do research on the laboratory scale, but also on the commercial scale to try to look at the enzyme impact kind of in real world applications. And if you want to share a bit with that with people.
Yeah, you're absolutely right, Chris. So, I mean, kind of as I mentioned about that, your mileage might vary statement with using enzymes in biogas. That's kind of what we're looking to see is folks who have a different mix of substrates that they're feeding to complete some trials so that we can kind of get a better idea of how this is performing with the different feedstock mixes that we're seeing here in the US. So we have a fair amount of experience over in Europe with the biogas and enzyme use, but the feedstock mixes are not exactly the same, especially if we're talking food waste. I mean, the diet here in the US is different than the diet in Europe, and it's different regionally here in the US, so, and seasonally as well. So looking for partners who are wanting to kind of and willing to explore some of this with us and share some of that data.
Great. Thanks, Lindsay. Okay, let's, so Dan, it sounds like the LSM pumps have been really well received kind of in the biogas world. And you mentioned some of the benefits that folks have seen. Can you dig in a little more and put a few more words around maybe a particular example where, some cost savings, whether in labor or O&M, have made a significant impact?
Yeah, sure, Chris. One particular project, long distance manure pumping, they were actually using a 100 horsepower pump to pump the manure between the farms. So we will be able to, we're still working on that project, I have to say, but to fairness, we are using roughly 25 horsepower to do the same amount. So it is in these calculation biogas. So you also want to, the equipment you want to put on, you also need to have an energy efficient solution for at least the pumps. On other, I would say, especially working with farmers direct on site, they also like the possibility to work on the pump themselves. They don't need to bring in a crane or special trained expensive guy to work on it. They can do it by themselves on the farm, and it's not a big job to do, and they don't need to crane anything out. They can just basically open the pump up like a door, and then you have free access. When you do a project, it's also nice to know that you don't need to put it in a dry well or a pit. You can actually put it on the ground, and basically it can stand out in any weather and conditions.
Great. And a quick addition, I know one of the projects you worked on had a high level of poultry poultry litter and therefore lots of feathers and other things. And that project was in dire straits. And can you just put a couple of words on how LSM helped with that?
It's still the details I have to keep to myself, but yes, we did a project. We're still working on it on the East Coast, pumping chicken litter, also with the feathers. There's still a lot of. We have engineers in-house, so we are working with the engineering company and the OEM to try to figure out the best solution. So we're still working on that, but it is possible to pump chicken litter.
Great. Thanks, Dan.
Thanks, Chris.
Soren, over to you. If I know that your biochop has been used in a lot of applications, can you put a couple more words about how the system may have been used at a wastewater plant or a food production application? I know you showed a lot of pictures of that, so maybe has this been used in a wastewater treatment application?
Yeah, it's more frequently used actually in the food production facilities, or directly at a biogas facility receiving various food waste sources. But one of the I think one of the pictures I showed was a chicken that unfortunately didn't make it to the supermarket cooler. So it went into the biochop, and we have listening to Lindsay's presentation, it reminded me of a project in Spain actually, where they also have a lot of chicken feathers. And while we can chop up and homogenize, the chickens and even the feathers, adding enzymes that Novozymes provided actually helped liquefy the feathers to where there was additional, feedstock available for digestion, whereas that would have been considered an inorganic, or part of the feather would have been considered an inorganic if we couldn't break it down. So yeah, it can be a good combination there. But poultry, it's used a lot in fish and slaughterhouses. It really varies a lot.
Great. And could you? I know we didn't have, we had short presentations, but I know your gas mix system, and this is a little bit off of directly on food waste, but can you just put a couple of words on the gas mix system and kind of how that helps to enhance AD system?
I'm happy to. Yeah. So one of the products that we do manufacture is a digester mixing solution that we call Landia Gas Mix. It's also based on the chopper pump there that you saw, but where we're using it on the anaerobic digester for mixing the slurry or the sludge. And it's a very, very effective mixing system where all mechanical components are installed outside the tank, and then we pump slurry and we pump it through a venturi that aspirates biogas down. So you actually get a gas mixing system in addition to the slurry that's being recirculated. But one of the benefits of it is that we're able to properly mix the digester. We're also able to increase the biogas production in many cases, and especially if you are using food waste in the digester, the gas bubbles that we inject are very effective at breaking up any surface crust that would otherwise form in digesters. So, but I'll keep it short here because that's a whole different topic today, I think. So thank you.
Yeah, great. Well, no, but thank you for that answer, Soren. And lastly, Paul Einer, you mentioned this project in New York State that you're working on. I'm not sure Cecilia used the word cooperative in her presentation, but for everyone's knowledge, most of the large centralized plants in Denmark are made up of multiple farms where, primarily dairy, anywhere from 10 to 50 dairies that might feed a central plant, along with all the food waste and other kind of agricultural residuals. Paul, I know you're working on one of those up in New York State, and as you stated, that might be something very interesting for Wisconsin to also explore. Can can you put a couple more words on kind of what that project looks like?
I can, yes. It's can you see me? Yeah.
Yes, we can. We're good.
Okay. It's placed up in Cayuga in the Finger Lake area, and the difference between Denmark and US is that by us, a dairy farm with 600 cows or dairies is a quite big dairies. You know, there are many small, whereas in US, a dairy farm on 1,000 cows is a small farm. So therefore, you can say they are not used for working together, and there are some resistance to bring manure from one farm to another farm or to a centralized biogas plant. They are afraid that it has some contamination of the bacteria from manure from farmland. So, but in this case here, we are working with, there are numbers of farms, and there is a distance between them. So some of them will have their own digester and their own gas operating, and then the gas is just distributed and end up in the pipeline. There are some farms which can go together, and we are trying to convince them that co-digestion of several farm manure is okay. We are recommending to use a thermophilic digestion, which are normal in Denmark, as also mentioned by Cecilia. It means that we have basically, if we can guarantee a retention time about 8-10 hours, we have a 100% destruction of any pathogen bacteria. That is one issue. Another issue is that we will reduce the cost for digestion about 50%. I mean, it's more efficient, it goes faster, and that's all the benefit. We do hope there will be, up to now, there is in contract with 3 farms, but there will be several more in that area. I think we were calculating up to 10 farms. That's what the developer is working with. So
Great,
it's
thanks.
very, very promising
Yeah,
project.
thanks, Paul. And I think that's we've started to see some of that movement here in the U.S. towards more of the kind of cooperative, centralized system, and I do hope we'll see more of that. We can't expect that every farmer is going to be able to support an individual project. So this could be something very interesting for us to explore with our stakeholders in Wisconsin. So thanks for that. Thanks for that overview. I think I'm going to quickly try to. A couple of questions that have come in have centered around kind of the quality of Gemidin Ekagi and the data collection on food waste. I know my friend Alex DePillis pitched a question. Alex, I may have to get back to you on exactly the data that's collected when the trucks come across the scale. To be honest, I've never been asked that question, so I don't have an answer. I can tell you that Gemidin has an incredible amount of data on the quality of their biopulp. There are very strict regulations from the Danish government as well as the EU on the quality of the biopulp and therefore the quality of the digestate that goes out on farmland. So we can follow up specifically with you. There was another question similar in nature about how hazardous chemicals and other things are dealt with in food waste. The Gemidin system in particular does not remove chemicals. And so much more of the focus is on enforcement regulations on what is put into the waste stream. And again, companies like Gemidin who are operating those facilities dictating that the feedstock suppliers deliver clean material to them. Another question, Peter, we may have to, Peter Wright from up in New York, had to deal with how can biogas and wind kind of work together. Certainly the power to X, power to gas discussion, continues, and I think there's going to be a great potential marriage between wind and biogas plants to put different technologies in place. I just saw a project that's going to be happening up in Maine with a biogas plant where they're going to use methanation technology to according to them, more than double the renewable natural gas output from that project by using that technology. And there's some good research by a couple of our companies, Nature Energy and Biogas Clean, specifically on that. And Peter, we can share some more of that later. And then lastly, a question about the standards for injecting RNG. Yes, that is done at a national level in Denmark, and those are very strict standards. And so unlike the US, where we still have to struggle with kind of a patchwork from state to state, in Denmark, that is done all at the federal level. So I think those are all the questions that I had seen, and we're about up to our time here. So I'm going to ask, and again, we will stay on if there are people, but only if you have questions and are willing to ask them. We will stay on beyond the end here. I'm going to ask. We'll go in reverse. Matthew for a few closing comments, and then Karen, and then I'll come back around for a couple. So Matthew, if I could ask you.
Well, thank you all to our presenters. I think that was very informative and necessary for the state of Wisconsin. I think that if there's opportunities for us to set up additional webinars on specific topics related to your areas of expertise, it's something we'll look for doing in the near future. And we'll connect, and anything we can do to help move this forward, I appreciate your time.
Karen?
Yeah, so thank you everyone for the presentations. Really fascinating technology. Had heard a lot about the Danish biogas, the various solutions in the biogas treatment market, but it was great to see those illustrated in action. So I do think there's absolutely benefit for Wisconsin. So again, thank you to each one of the presenters and to the Danish trade group for helping bring all this together. And we do look forward to future conversations. So thank you all for being part of this session.
Thanks again, Karen and Matthew, for collaborating on this. I think it was very successful from our side. And just based on what you and Matthew said, I think when Cecilia showed some of our other companies, I do think that there could be a very nice opportunity for us to maybe focus on biogas energy. So more on that side of the equation, as well as the centralized model. Cecilia mentioned Nature Energy a couple of times. Just for everyone's information, Nature Energy has been working hard over the last 4 years in both Wisconsin and Minnesota on a Danish model project, if you will, and we are, holding out great hope that may be one of the first places that they're able to build a project. So we will be looking for doing those. From an administrative side, all the presentations will be made available to everybody after the fact, as will a recording if you choose to watch again or share it. If I could ask for the last slide to be put up, I think it's got all of our contact information on it. So please reach out to any of us if you have questions on biogas, on wastewater, on any of the companies, or obviously Wisconsin specific to Karen or Matthew. When we close, we would appreciate if you'd fill out the survey. It's very, very quick. It helps us make sure that we're addressing the issues that you want to hear about. And yeah, again, thank you for the speakers from Denmark and the States for their presentations. We do believe there's a great opportunity in Wisconsin for growth in biogas across all the different sectors: wastewater, livestock, food waste, and we'd love to share these solutions with you where they make sense. And so with that, we're gonna close the formal webinar. And again, we will hang on and see if anybody stays on the line and wants to engage further with any of the speakers. But now we will adjourn the formal program. So thank you very much for attending.